Hi, I thought I would take a few minutes just to go over the fraction presentation that I've shared with you in the classroom already. It is something that you could utilize anytime you're having trouble with fractions, but I thought I would kind of walk and talk you through it. So, the very basics of the fractions are that you know that there are two parts to a fraction. There's the numerator, that's the top number, and the denominator, that's the bottom number. The top number represents how many pieces you're talking about or that are being counted. The bottom number represents how many pieces there are altogether, and they have to be of equal sizes. So, if I divided them into four equal pieces, that's why there are 3/4 shaded. And this shows 3/4 as well. It doesn't have to be a circle, it doesn't have to be a rectangle, it just has to be something divided into equal pieces. Now, there are different types of fractions. I'm not going to spend any real time on this, but unit fractions, these are those numbers that are the numerator on the top is 1. So 1/4, 1/3, 1/6, 1/9, 1/5. Proper fractions are when the number on the top is less than the number on the bottom. That's why it's a fraction. It's just part of something. It's a fraction of something. It's not a whole. To be whole, the number on the top and the number on the bottom would have to be exactly the same. Like 9 out of 9 is one whole. 100 out of 100 is one whole. Then you've got improper fractions. That's when that number looks top heavy and the number on the top is bigger than the number on the bottom. That's improper. That is not really a fraction at all. It's called an improper fraction. It is more than a whole. And in a minute, we'll talk about how you solve those. And then you've got mixed numbers. That's when you've got a whole number and a fraction. So if I said I had 3 whole pizzas and 5/9 of that last pizza, it'd be 3 and 5/9. Now, adding and subtracting with like denominators, that means the bottom number is already the same. They are the same size piece, is easy breezy. You don't ever add the bottom. You never, 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 ever add that. That's the size of the piece. That's not going to change. But this is the quantity portion of it. So when you're adding fractions that have the same denominator, let's say you have a pie and in the morning you had 2/6 of the pie, and then after dinner you had 3 more 6 of that same pie. Altogether in that whole day, you had 5/6 of that pie. So you add or subtract the numerators, the denominator stays the same. These are the easy ones. When you get to having to add or subtract with unlike denominators, those pieces aren't the same size. You can't add or subtract them. You need to have the same bottom number. So the trick that you were shown before is if you can get from the smaller number to the bigger number by multiplying somehow, that's the way to go because then you only have to change one fraction. Unfortunately, this in this case, you cannot do that. You cannot multiply 3 times anything to get you to 5. So what you do is you take the opposites. You're going to multiply this fraction by 3 and you're going to multiply this fraction by 5. So down here, when I've done that, I do whatever I do to the bottom, I do to the top. I multiplied this to get 15 on the bottom. So that gave me 6 over here. And to get 15 on the bottom over here, I multiplied by 5. And then I multiplied by 1. Now, when I add them, the bottom number stayed the same. I worked hard to get 15 to be the same. You simply add the top numbers, and now you have 11/15. Multiplying fractions and dividing fractions is really super easy. In fact, it's way easier than adding and subtracting, believe it or not. In this case, you literally multiply the numerators, multiply the denominators, and you are done. 3 times 2 is 6. 5 times 3 is 15. Very unlike adding or subtracting fractions. When you multiply across the top and you multiply across the bottom. Now, in the event that you have a whole number times a fraction, all you have to do is stick a 1 underneath it and you've made it into a fraction. You haven't changed its value. 6 over 1 would really be 1 divided into 6. That's still 6 whole. You can make any whole number into a fraction by sticking a 1 underneath it. And now guess what? You multiply across the top and you multiply across the bottom. 6 times 2 is 12 and 1 times 5 is 5. Now, it's an improper fraction and we're going to show you how to fix the improper fractions in a minute. Dividing fractions, one extra step. Actually, you never divide fractions, you multiply. You never divide fractions, you multiply. What you do is you keep the first fraction the same. That's what that K is for. Keep the first fraction the same. You flip the second fraction. You cannot flip the first fraction. It has to be the second fraction. You flip it so it's upside down, and it becomes automatically a multiplication problem. So 7/8, the first one, stayed the same. The second fraction got flipped, so now it's 5/2 instead of 2/5, and now it's a multiplication problem. Multiply across the top. 7 times 5 is 35. Multiply across the bottom. 8 times 2 is 16. It's improper. When you divide 16 into 35, it goes in there 2 whole times with 3 left over, and the denominator stays the same. We'll spend a little more time on that in a minute. The butterfly method, what a great way to compare numbers. Make your circle so it looks like a butterfly. Multiply the two numbers you've circled. So 3 times 2 is 6. 5 times 1 is 5. And you see that 6 is bigger than 5, so that greater than sign, that mouth. I like to think of that as a mouth. That mouth is going to face the bigger number every time. Now, improper fractions to mixed numbers. You've already seen this in that Ed puzzle video, but one more reminder. These are just division problems waiting to be solved. That's all a fraction is. It's a division problem. You divide the bottom into the top. So if I said 5 will go into 12 2 whole times, I know this because 5 times 2 is 10. It won't go a third time. So it goes 2 whole times, and since it's 10 and this is 12, that's 2 left over, and the denominator stays the same. 5 divides into 5 1 whole time, nothing left over. The answer is simply 1. You divide the bottom into the top. How many whole times it'll go in there? If there's anything left over, it becomes the numerator, and the denominator stays the same. You do the exact opposite when you want to take a mixed number and make it into improper. You're not going to need to do that in math lab, but you will eventually need to know how to do that. And you literally do the opposite. If I divided last time, I'm going to multiply. 2 times 5 is 10. I'm going to add then what was left over, the 2 up here, 12, and that gives me 12/5. So you multiply the whole number times the denominator, and you add the numerator. 2 times 5 is 10, plus 2 more is 11, 12. 12 goes on top, and 5 goes on the bottom. Simplifying and reducing, I personally think, is one of the hardest things because it involves division. But as a quick reminder, we did this last week, but as a quick reminder, you find a number that will divide evenly into both the top number and the bottom. Like all fractions, whatever you do to the top, you have to do the exact same thing to the bottom. So in this case, 3 is the biggest, and you want the biggest number so that you don't have to do it more than once. I divide 12 divided by 3 is 4. 15 divided by 3 is 5, 4/5. 25 and 40 can both be divided by 5. 25 divided by 5 is 5. 40 divided by 5 is 8. You can't reduce those anymore. Hopefully this helped, and you can look at this and review this slide presentation on your own or the video of the slide presentation anytime you need.